Hey guys, I'm here to talk about a new form of VR locomotion. I'm not actually sure how recent it is, but it's new to me and I haven't seen too many things using it. I've only actually seen one thing use it. Um, so currently the main forms of VR are teleportation and anchored movement sort of things like that, which is the way teleporting works is you just blink from one place to another instantly, and anchored movement is centered around you being within something, so that your eyes have a form of reference to uh, make sense of what's happening with your movement and your vision. Uh, so if you were to use just regular FPS movement in a game, typically you tend to get nauseous after a while. This is due to vestibular uh, mismatch, which is when your air fluids don't synchronize their movements with your vision, and that can cause some nausea after a while. So this new form of locomotion, it's centered around trying to create some sort of, you probably can't get exactly the relationship, or I haven't, but you might be able to get close to it. It establishes some sort of relationship between the movement in your ear and your vision, so that can reduce the amount of nausea and also allow you to use FPS style camera movement, and just it creates a better sort of immersive experience for virtual reality games. And I think that it probably should be the best way to get around. Um, yeah, a lot of the reason why VR is slow to get adopted is because of the clunky locomotion. So I'm hoping this might fix it, and I'm putting this up there so that other people can use this method. Yeah, I'm only putting up this in a very essential form, so you can apply whatever sort of ideas you think might help to make it more fine-tuned and a better experience. But yeah, so the way this new method works is, what I've done is I've tracked the amount of movement that your head has when you move using the VR. When you basically simulate running, like you pretend to run on the spot. So when you pretend to run on the spot, your head will bob a slight amount. From that slight amount, you can generate some sort of formula as to how much the person should move if they bob that much. Say you took a big stride, your head might bob a lot, so that would mean that you should move the camera forward a lot. Yeah, I've set up some variables in the example that you can just fine tune to whatever suits your purpose. Say you were like pretending to be a giant, you might make the head bobs equal to a large distance or something like that. Yeah, so in essence, it's just matching up your head bob movements with the camera moving. I'm just gonna do a simple demo. It's probably not too complex. Yeah. Alright, so I'll just get into it. One second, a bit new to this. So we'll just have a blank scene. Yeah, we'll just have a blank scene. I'll add a plane just for reference. Reset the plane, I guess. And maybe make it 10 by 10. 10 on the X, 10 on the Z. I've included the standard assets. You don't need to do this. It's just so that you can better see the movements. Well, at least I thought it might be a bit better. And then I included the Steam VR plugin. You can get both of these just from Unity. For the standard assets, you just go into, I think it's here, packages, and then environments, and you just import all of those. And then for the Steam VR plugin, you just get it from the asset store. You just type in Steam VR, it should come up the first thing. Yeah, so you don't have to do this part, but what I'm going to do is just put grass on the ground so that you can see when you move instead of just being a blank material. I'll also just put a cube. You can do this, pretty easy to do, in front of the camera. So, there. And what else will I do? Yeah, that should be okay. And also you need to swap out the default camera for Steam VR's special camera, the camera rig. So I'm gonna reset that, and I'm gonna move it up a bit, move it back a bit, just because. I'll just save the scene as something demo scene. I'll just demo. Okay. So from here, you want to attach a script, demo head bob movement, maybe demo bob movement. Sure, why not? Okay, from there, you open up the script to Visual Studio. You can just ignore the coloring and stuff, that's just some extensions I have there. Yeah, so the things you want to get reference to are, you want the player body, so transform, public transform, so that you can reference it in the editor of the body, public transform of the eyes. So I've done the transform of the eyes because at runtime Unity seems to delete the camera rig head and just include the eyes. I'm not sure if it always does that, but it does that for me. So public float stride mult. That's going to be how far you want to step based on your head bob movement. So that's where if you're like a giant and you want to move a lot for a head bob, you would amp that up a lot. What else? Last position for the eyes. I'm doing this just based on the update frames and the position instead of velocity and rigid body, because it just seems to track a bit better and it's more responsive, and really you want a lot of responsiveness when it comes to eye movement and reducing nausea. Okay, so Victor 3, last eye position. I'm just gonna set that to be the eye position when the game starts, for like basically just initializing it. So last eye position equals eyes dot position. Yeah. What else do we need? I'll just include that for now, then if I remember to add more things, I'll add them. Okay, so basically you want to evaluate if the eye has moved since the last frame. Oh, actually, yeah, you might want to include a threshold, which is basically if the head, because your head will always move when you're playing, so you can set some sort of value to only move when you've moved a certain amount in between frames. So you would have to play around with this a lot, but what I've done is just put a movement threshold float that you can just set and fiddle around with later. So if the eyes have moved, last eye position, I'm only checking the Y axis so that is only evaluating the bob of your head and not anything else. So if last eye position is different to the current eye position, so eyes.position.y, you initiate some movement. So the first thing you can do is figure out how much the Y has changed. I actually don't need a vector for that, so just go ydiff equals eyes.position.y minus last eye position.y. You should get the difference between the head bobs and between the frames. The way it works is, because it's an update, the difference will always be some sort of, it will be in scale with time.delta time, so you don't need to do like all those random like multipliers by time.delta time. Yeah, so we'll also add to the conditional that it's over. Oh no, we won't, sorry. So from that, we have the difference. We can check if the difference in movements is greater than the threshold. That way, it will only move if you move a certain amount in case you want to look at something. You don't bob your head as much as it expects you to. Alright, so initiate the movement. We will grab the body. So the body dot position equals body dot forward. Sorry. And then you would move it by the body dot forward on the x-axis. You don't want to move the y-axis because otherwise if you're looking up and you bob your head, you will start flying up. You could include it if you wanted to, but it wouldn't really make sense because then gravity wouldn't be applying to you and you wouldn't be bobbing anyway. So body dot forward just on the x and z axes, forward dot z. And for the forward dot z, you want to multiply it by the difference, the y difference. So basically what this will do is it'll, oh, what have I done? Oh, yeah, sorry. You don't want to use body.forward, you just want to use a new vector 3. And you want to use the body.forward for the x and z. This is so that you just don't move like only forward, you will actually move in the direction that your camera is facing, like as you normally would when you're running usually. Yeah. And so let's see if this works at the moment. First off, we will have to save it, then add the references and add the script, I think, if I haven't added the script already. Yeah, I have added the script, so that's fine. So for the body, you'll want to drag in the parent for the camera rig, which is basically like your body. And for the eyes, you won't drag in your head, camera head, you'll drag in camera eyes, because head gets deleted at runtime for some reason, not really sure why. And so when I play, hopefully, I'm flying. Is that right? What have I done? Oh, okay. What I've done is I forgot to set the last eye position so that it stops incrementing. So float diff, then last eye position equals the new. So basically just updates this just updates the last frame for the eye so that you can tell if you know, you can just tell if you've moved or not. I think I've also forgotten to convert the Y difference into an absolute value, and I purposely left out scaling it at the moment, but we can possibly add that now. So I'll just, first off, you want to include systems, using system, so that you can use math.abs ydiff. Basically all that does is it converts a negative bob, like a downward bob or an upward bob. They'll both be positive values so that your camera won't sway randomly. What else? That should work for now, I think. I'll add a small threshold. Sorry, I forgot to do that in the thing. What I did was I added this here just to make the negative and positive Y differences always be positive. And I added this, so what this does is it resets the previous frame's value of where the eyes were at to the current frame, so that when the next frame comes around, it won't just like accumulate or be different, too different. And I also included using system so that you can use math.absolute. Yeah, so hopefully try that. Also, I will add a threshold value to the movement so that just goes. So we try 1.001. I'll play that. So if I bob, it's kind of hard to see, but if you look in the transform, you can see little bits of movement. Right now it's just doing the z-axis. I think I might have messed something up there, but yeah. So see how it's slowly getting closer to the camera? I mean, yeah. So this might be a good time to add in the stride multiplier and maybe fix up the something rather. So we can go into there And for the movement, we can multiply it by, so we can multiply the movement by the y difference, which, sorry, by the stride mult. So stride mult multiplied, actually you can just do this, use that operator, and I think maybe we might need to add the y difference to this, y diff. So try that. Oh yeah, because I forgot to set the, yeah, so we tried that. We tried to move now, but it didn't work because we forgot to give stride multiplier a value. Currently it's 0, so it won't evaluate to anything. So just save it and I'll run it. Yeah, so it's moving forward, but it's not moving sideways at the moment, so I think I can fix that. Hi guys, I had to pause the game because I couldn't get it to walk forward properly. That's because I was basing the forward vector, forward floats off the body of the camera rig, which is here, because that doesn't really rotate, was only moving forward. It kind of was working as intended, it's just that the body wasn't moving. So what I have done is changed it to, I've changed it to, one second, I changed body.forward here and here into eyes.forward, and now it should work as intended. If I exit out of there and I play it here, yeah, you can see how it's moving in the direction of your eyes. At the moment I'm bobbing a lot to get it to move, so you can just change the script here. Say I want it to 4. Now it's moving a bit easier. Could change it to 40. Now I'm quick. Yeah, and it just helps for reducing nausea. So hopefully you can use this in your games to be useful for immersive first-person movement. Thanks for watching. Bye.